Alright, welcome to the video. This video is about linear and angular velocity. We're just going to kind of touch on the definitions and our formulas, and then tomorrow in class we will go over some examples of how to use these. Linear velocity is the rate at which any object moves with respect to time. Angular velocity is the ratio of the angle traversed to the amount of time it takes to travel through that angle. When we talk about angular velocity, we're talking about an object that is moving in a circular path. So angular velocity, otherwise known as omega, is defined as omega equals theta, that would be the angle that we are traversing, divided by t, which stands for time. And notice that our angle is going to be in radians. It is very important to make that distinction. And if it's not in radians, we will be converting it into radians from degrees. So again, omega represents the angular velocity. Theta is our angle that is traversed. And t is the time that it takes to traverse the angle. Theta would be similar to our central angle that we have been working with as we've been finding arc length and area of sectors. So go ahead and pause, make sure you have this copy down, and we'll finish up with the rest of the notes. Now we're moving on to our linear velocity formula. Linear velocity of an object traveling in a circular arc. And again, this is for when it's traveling in a circular arc, is going to be linear velocity equals the length of the arc divided by the time. Or v is equal to s divided by t. If we know the angular velocity already and we know the radius, then we are going to be using the formula linear velocity is equal to omega times r. Go ahead and pause and finish copying these down, and then make sure that you go back and you answer the questions that will be embedded in the video if you have not already done so. And we will see you in class tomorrow. Have a good evening.